Here we go with a 2-column proof. And I've chosen something which is real. Real for you all in the room and real for you all at home. You can look at this with your hands. You're going to need a couple of things. You'll need 2 pieces of paper and a straight edge if you can get one. A protractor would be helpful, but is not necessary. Not necessary, but it's going to help you convince yourself that this 2-column proof that we're going to do here works. And I've got a pen that I'll be able to see on white paper. So I'm going to use 2 pieces of white copy paper and these tools, and I'm going to demonstrate something that I can not only just do over and over and show somebody as kind of a trick or an entertainment, but prove to myself using math to support it. Prove why this works. And this is where we've been going in the last couple of weeks, to go from solving equations to proving them. So here we go. I moved my materials out of the way, and I have a piece of paper to demonstrate. A piece of paper. And here's the idea that we are going to prove to ourselves. We are going to fold 2 corners of a piece of paper so that their edges match. And we will create a 90-degree angle. And we're going to prove to ourselves that it's true every time we fold 2 corners of a piece of paper so their edges match. We create a 90-degree angle. We are going to prove it to ourselves. So let me show you. I'm going to take one corner here, this corner, and fold it towards the middle. Fold 2 corners of a piece of paper so their edges match. Okay, there's a fold. Take a second corner and fold so their edges match. So I'm lining them up, and you'll know this fold from paper airplanes. Okay, I've taken 2 corners of the paper, folded it towards each other, the edges match, and what Mr. Mitchell, Ms. Sitek, and Mr. Scott are saying is that this crease, what we just created, what we're telling you is that this is a 90-degree angle, and we can prove it. Whoa, does it look like a 90? Yeah, it kind of does. Kind of looks like a 90-degree angle, but I'm skeptical. Well, I want to try it again. So I'm going to change what I did there. Okay, this one was kind of towards the middle, both sides. All right, I'm going to change it over here. Now I'm going to make it kind of shallow. Yeah, what do you think about this? Try to make a 90 out of that. Okay, so there's the flap there. And then this one has to come over here, and so that the edges match. Okay. Edges match. Well, what's it look like? I'm going to use my Sharpie again so that you can see where the crease is. Well, it kind of does look like a 90. You're telling me I can not only do this every time, Mr. Mitchell, but I can prove it? I don't know. I'm still skeptical. One more time. Let's see. I'll try doing this. And then this. This is a different one. Lining it up so the edges match. It's kind of a paper airplane fold. And once again, I can see that crease, but let me highlight it here and here. So maybe I've seen something like this in a math class that says, you can do this as a trick, but here in high school geometry, you're telling me that we can prove that each of these is a 90-degree angle? I don't know. Prove it to me. Prove it to me. Okay, so keep this piece of paper. This is the one I want you to show to your parents or somebody in the family who has either a good or a bad history with math, and you're going to tell them, I can prove to you that if I fold two corners of a piece of paper so their edges match, it'll create a 90-degree angle. I'm not just going to show you something that looks like a 90. I'm going to prove it. Okay, so your second piece of paper comes in here. Second piece of paper. Okay, so I'm going to work on this 8.5 by 11 piece of paper. I'm going to do this one more time at the top, kind of in the middle, so that I can make notes under it. So I'm going to make my fold here, and then I'll make one here. All right, and so just a little bit different this time. You know, I'm lining these up. When you bring the edges together, so this is kind of how it looks originally, and I've brought my edges together as best as I can. And with your pencil or your pen, what I'm going to do is just kind of squash the paper flat there and make some little marks right where the seam of the paper comes together. So I'll be able to see a little bit of ink or pencil lead if you do use a pencil when I open this up like that. Okay, so there is my seam in the paper. And I'm going to use a straight edge. I've used the side of a calculator before. I've used all kinds of things if you don't have a ruler handy. And there is the line that brings those two together. Okay. So here's our 90 again. I guess I'll color it with the lighter ink. This one's going to be not as dramatic as the Sharpie, but I'm just going to darken it in so you can see it at home. And there. Okay, so there's our two folds. And we used a little spot of ink to kind of show the line up the middle. And all right, now we have to prove it. A two-column proof. Folds make a 90-degree angle. So a two-column proof has two parts. There are two columns. There are statements, and we are going to prove each one. And there are reasons, and this is the reason why. So if we can work from the beginning, some sort of given information, through a proof step by step with deductive reasoning using facts, definitions, logical arguments, and reach a solution with reasons given each time, we are providing proof that the math works. Okay, we're going to do a couple more things up here to set up What are we given? Well, in the math sense, here's something we covered in the first unit. We know we are given that a straight angle is 180 degrees. Okay, so this proof is going to start with the idea that the straight piece of paper right here, the straight edge of the piece of paper, is a straight angle. And we know from a geometric definition that we studied earlier in the semester that a straight angle is 180 degrees, 180. We're given that. And now, so we can do some labeling. I am going to show here that we have essentially two angles only. We have this angle 1 and this angle 1. They are part of the straight angle. I've named them both angle 1 because this is folded in half, right? You fold this piece of paper over. So this angle 1 and this angle 1 are the same size, and they meet at this line here. So these two are the same size. They are it is one bisected angle. And then there's angle 2 and angle 2. This is the second of the angles. Like a paper airplane has two sides. If you fold this one over, you can see that these two lay down right on top of each other, and they are the same. And so we can use a previous definition to say that our straight angle is here, and it's made up of these four angles. Okay, so starting from the very top of the two-column proof, let's use our given information. A straight angle, so this is where we start proving our math. A straight angle is 180 degrees. And the reason we can say that is that this is a given, and it's a definition in geometry. We studied it in the first unit. Okay, so there's reasons. The straight angle is 180 degrees. This is the straight angle, the flat top piece of the paper. Okay, and so then we have a number that we can use as a sum. And I'm going to just take this, my two angles we're working with here, and I'm going to say that the measure, I'm using a sentence, a math sentence, and some symbols here. The measure of angle 1 plus the measure of angle 1 again, plus the measure of angle 2, plus the measure of angle 2 equals 180 degrees. We've taken these four, 1, 1, 2, 2. The measure of those angles, whatever those angles are, they should add up to 180 degrees based on this definition. And the reason we can add all these angles together, well, we've studied that too. That is the angle addition postulate, also from Unit 1. A postulate, something we take as assumed to be true. The angle addition postulate just kind of says that we can add adjacent angles. So angles that are next to each other can be added in value. We don't know these numbers yet, and we may not ever here if we don't measure them, but we know that we can add them up and sum 180 degrees. Okay, so Ms. Zytek covered some of the properties of algebra here. So I have got my algebra eyes on, and I want to simplify this. Well, what I really have is two of each. So here is a simplification that I'm going to try. 2 multiplied times the measure of angle 1 plus 2 multiplied by the measure of angle 2, because that's what I have. I have 2 of each, and these sum to 180 degrees. And guys, when you talk to adults older than you who took geometry back in the day and they did proofs, some of them will bring up hard memories. And that is because you're going to have to tinker with math to go from one to the next. I just had to stare at this for a while to think, well, what can I do with this math? I guess I could simplify it. So I'm going to go down this path and see if this can prove my math to me. And what I did here, the reason I can do that is it is a simplification. I have just simplified something. If I have measure of angle 1 plus the measure of angle 1, I have 2 of them. And I'm adding to that 2 of the measure of angle 2. But this brings out something interesting. If I have 2 multiplied by these different values, I may bring it outside of a parentheses. And then I can say the measure of angle 1 plus the measure of angle 2 equals 180 degrees. And Miss Sitek covered this yesterday. Going from here to here uses the distributive property. We're just using it backwards, what we tried yesterday. The distributive property says that I can pull out a common factor. These are both multiplied by 2, so I can put the 2 on the outside. I would use arrows to distribute to go back to this version. And there's one more move that I'm going to do here. I'm going to divide each side by 2. Because they are both divisible by 2, I can make it even simpler by doing this. And I will have a result of this. The measure of angle 1 plus the measure of angle 2 equals 90 degrees. And I have justified this with a reason. An established mathematical technique, I use the division property of equality. I think we did it. We went from given information that this is a straight line, which in geometry has a measure of an angle, 180 degrees. We used 2 folds to demonstrate congruence in 2 angles. And then we walked through some properties of mathematics from a straight angle is 180 degrees. It is the sum of those angles. Rearrange the math a little. There's 2 of those and 2 of those. Use a distributive property to pull the 2 to the outside. Divide by 2. And suddenly we have this. The measure of angle 1 plus the measure of angle 2 equals 90 degrees. This has been proven to be a 90-degree angle. Look back at your other piece of paper. You know, guys, distance learning it's hard to do. If you're at home, start with that one. Go to your crazy uncle, your funny aunt, your neighbor who's kind of interesting, and see if you can retell the story of this, because that will help you learn what you're doing here. You're not just solving equations, you are proving it. And this style of proving, and there are many, this style is called a 2-column proof.